Okay, so let's start with the composition. Before we talk about that, I want to talk about the assignment first, this project here. So if you, it's in the unit 4 right below here, okay? So I have a Google Doc, and this, I'll give you 2 weeks to do this assignment. Okay, it's a 300-point project, so it may be easy if you understand the concept. You could do this within an hour or two. Okay, if not, if not, then just kind of go over the video I'll be recording tonight, as well as read the book, and also I'll be do some examples so you can see how that works. Okay, but here is the project. So for this project, this is basically just from the textbook. I modified it. Okay, so it's in the textbook at the end. I think this is like number 5 of the exercise, number 5, A, B, and C. But what it had there was not really nice, so I'm going to change it around. And so basically, you have 4 parts here, and each part here is just basically it's a class. Okay, so the first part here, you're going to create a class called bread. Okay, you can save that as bread.java, and if you're using IDE, it's automatic save for you already. It's fine. And so this bread class is going to have 2 fields. Okay, one is going to be the bread type. So you can call it whatever you want. You call it bread type as it is, or however you choose it, that's fine. And then another variable we call calories per slice. So you can see that, okay, the bread type will be string type, right? And the calorie is probably a double. You'll be getting the decimal numbers. And then you can include a constructor. This constructor will take the 2 parameters for each field, like we did. So this constructor will take the bread type and the calories per slice, and then updates those values. Okay, and then you also want to create the setter and getter for those. If you remember, do those last time to set the data and also retrieve the data from the field. So if you want to create an object called bread and supply the value of the type would be rye, and then the calorie is actually 50 calories per slice. Okay, then I can set you can use like set bread type, and you pass in the value of rye, and the set calorie per slice pass the value to set that. And to get it back, you just say get bread type, and it will return that data type back. Okay, so you do that for that one, and also include another final static string called model, and then you set the value to to just this little string text here, set to that. So it's just a final variable, constant variable. So that's part A. Part B, you do exactly the kind of same thing, except now it's a sandwich filling class. So it takes another parameter called filling type. Okay, and then another one is again calories per serving. This is per serving. This is per slice of bread. And then you do the same thing. The constructors to take those 2 parameters, and then the setter and getter and so on. And you save that as this class. Okay. So when you build this class, these are not your main program class. So you don't include the main method in here. Okay. So no main methods. And then part C is same thing. You have a sandwich class. Okay. This was a little bit tricky now. So the sandwich class has a bread field and a sandwich filling field. Okay, so it's using class as data type now, not string or integer. Okay, but the way you do it is exactly the same as you would do in the normal it's okay, as a regular data field. Okay, so you do it again. You supply constructor and you pass the parameters to those. So the parameters will be the bread type and sandwich filling type. Okay, and you again the setter and getter to update and retrieve those data and save that as sandwich Java. And then finally, this is the application. So the application, I call it test sandwich. It doesn't matter if you call it test sandwich or not. You call it whatever you want, doesn't matter. Okay, this is the main one. So the main one has to have the main method in there. So this is the only class that will have the main method in there, because your program will start from this class. And then in that class, you're going to write you're going to create 3 I think it's 3 sandwich objects. Okay, and then those 3 sandwich objects, you'll be using the sandwich class to instantiate three objects. We call it S1, S2, S3, right? And then you assign the name, the type of bread, the calories per slice for the bread, and then the type of filling, as well as the calories for that per serving. Okay, and then you're going to write a function to calculate that. So you calculate the calories, and it says this function here takes two parameters, the bread and the filling. I'll show you how to do that in some examples. And we'll assume that each sandwich is made using 2 slices of bread. Okay, so the 2 slices means that, so one slice has X calories. So 2 means you have to times by 2, right, to get the double calories in your calculation. So when I do a test run, and then you also write a method to display the data to the screen. So when I do a test run, it will look something like this. So I output the static data, which is the model staff life. And then, again, this is just formatting issues. So I kind of formatted the bread 1, the bread type is rye, and then the calories per slice is 50, and it's egg salad, whatever it is, and then calories. And then the total calories is 50 times 2 plus that, right? So you get 250. So this is your bread 1 type. The bread 2 type, you have different type of bread, different type of filling, and the bread 3 type, and you print that out. Okay?
Now, did you use different when you have bread 1 and bread 2 and bread 3? Were those just print line statements?
Yes. Yep, all these print line statements here. You could, so when you use a function to print your bread 1, bread 2, or bread 3, you could pass a parameter to that function. So, so you can print the number here. Otherwise, how would you know if this is bread 1, this is bread 2, and this is bread 3? Okay. I'll show you what that means. Okay. 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 So so this is the idea here. But before we get to the output, let's go with this concept here, and I'll show you some examples using the composition here. Okay. So I'm going to create a class. What should we call this class? Let's call this is the car. Okay. Car class. This car here is not going to be my main one, so just going to car without the public. So I have a car class. So let's just say the car is going to have a name. Okay, so string of name of the car, and also has maybe a speed. Okay, so it's going to be of type double. Okay, so typically when you do your classes, you make sure all these are private data. Okay, so private data. Okay, so that's the only two I need. Then I need to create a constructor to build this data, to accept the value of those data. So have a public car, and you can avoid the empty one. You can use an empty one like this if you want. That's fine. If you don't supply, that's okay. But basically, you need one that would take both of those values. So the first one could be a name, and then the second is the speed. Again, doesn't matter which order you choose. Okay? So, in this part, you could do it either way. One way is you can use this name. Okay, this name refers to this name up here. Okay, is equal to this name here. Again, if it is confusing to you, then changes to new name. Okay, because it's the new name that's coming in, and then you can use that new name here. That's fine too. It's completely fine. So it doesn't matter what you call here. But typically we'll just call it the same as this. So when you have a lot of variables, then it becomes confusing if you don't have the same name. Okay. So if you call this X or C, then it's like, oh, what is C, right? But if you say, oh, exactly the same as name, then I can refer that, oh, name is the name, so therefore it's a name. And use the keyword this here. And the this here is a reference to the object. Because remember, you can create a lot of objects out of this class car. I can create car 1, car 2, car 10, whatever it is. Now, that car name is, whose car's name is it? Is it car 1 or car 2 or car 5 or what? Who is it? So it uses this keyword, this car, is referred to that current car, whichever the car is, that call this function, this constructor. Okay, so it's always used by this car, this object here. So I'm going to initialize the name to that, and then I'll initialize the speed to the speed that is coming from the constructor. So notice I initialize this value by accessing the data here directly, right? The variable directly using this one here. However, I also ask you to create some getter and setters, right? So the setters and getters. So how do we create setters and getters? So a set is, again, just a function, a void function to set data. It does not return anything. A getter is a return function. Okay, so to set the data for the string of name, this is the convention. You say public void. I'm not returning any data. I'm just setting the data. Set name. Okay, and this set here, it tells you that it's a setter. As initializing the data, the name here is the name of this variable up here. We capitalize it because using the camel casing. Okay, so you see this, you know, oh, I'm setting the name for this variable. If you don't do that, if you say set, you know, t, what is t, right? Doesn't make sense. It would still work, it just doesn't make sense. So you typically use the same name as your variable name. And then I'm passing the data to this function to set the value. So I'm going to pass the same thing. It's going to be a type, string type. And then here, all I'm doing is now name is equal to name. So if you look at this, I mean, don't these two look familiar? Right? So in this case, it's redundant. Okay? So you could do it this way, which is fine. I'm not going to mark you any points for that. Or you could do it this way. You can say, instead of doing this, I want to use the function here, the getter, the setter to do for me. So I can say set name and pass the name to it. Okay? So you call this function set to set the name. And the same thing down here. I'm going to have a public void set speed, and it's going to take a double speed, and same thing. So it's going to be this speed is equal to speed, and then I can, you know, replace this with just set speed, and then pass that to the function, and the function does the job. Okay, so this is your setters. Setter, again, you're passing data to the function to set the value. The getters, you don't pass anything to it. You just want the function to return something back. Return what? Well, return the value that was set to this function here, or this variable here, right? So the getters, you're going to return the type of, for this name, I'm going to get a type of string back because it takes a string, right? And it's just going to be get name. So it takes no parameter because it is not going to set anything, and it's going to return this name. That's it, right? Return that name. And we use the same for the get speed. Give me the speed of this car, or return it. Return what? Return this speed. Okay? So return the speed back to whoever requests it. So this is your setter and getter. And then, so inside your constructor is usually always the setter to set your initialization here. Because you use the constructor to build that object called car. When you build it, what the speed going to be? Well, usually the speed is 0, right? So you want to set the value to that, whatever that is. Okay, and now when you want to retrieve the data back, then you don't do that inside the constructor. You do it in a separate function call to do that. Okay, so I build my class of car, has 2 parameters, and I have a constructor to build that object called car, and I have my getters and setters to assign or initialize those values, as well as retrieve those values back. Okay? Are we clear here? Okay, so now I'm going to create another class, and I'm going to create a class called maybe we just call it a racing or something. Okay, so let's say this is my main program and racing program here. So this is the main one I'm going to create using this method public void main. Include that in there. Okay. Now if you look at this, I have a class called car, which is this one here, another class called racing, and they're in the same package called default package. Okay, in the same folder. So therefore, we call this package. If they're in the same package, and therefore I can access this data here, even though they're in a separate class. Okay, if I have another folder called maybe another package, then I can't really reach out to that class unless I include that in the package. But we'll deal with the package later for now. So I have a second class here. This is my main class. So I'll just put some notes out here. Maybe main program here. So I know this is my main program. And how do you know? How do you know this is the main program? Yeah, the main method, yes. Yeah, so the main void method here, this is your main program. Okay. So now, how do I create a new car object in this main method here? So they're the same package. That means I can call this car directly by using the same way as I did with the string. Remember, string is a class. Okay, the scanner is a class, right? So I can just say car, and we'll call this maybe car1 is new car. Okay, if I do this, you see there's a curly squiggly line here. Why is that? What do you think that is? Yes, right? Do we have a constructor that doesn't take any parameters? If you look here in your constructor, we don't have one, right? So we either you have to build one here, or you have to supply these two parameters here to this constructor to make it work. So since I don't have the blank one, I have to supply one here. So I have to supply the name, and if I do, let's see if I do this. So the first one is the name. I guess we'll call it kit. Gotta be fast. And then the speed for that, initially let's just put 0. Okay. So now it's happy. So I have a new car 1, and it's initialized to kit, and it has a speed of 0. You can have other functions in here, other properties. We call it start engine, stop, and then switch gear or something like that too, right? But for now, let's just say we have that car speed. Okay, so now I'm creating a class object of class inside this class. So this is a composition, okay, because I'm including another class that I created inside another class, an object of that type. Okay. So this is a local variable within the main. How do you make it global? Yeah, you just basically move this up out here, right? See, it works just fine. If I do this, I have a global object. It's in global space. Okay, so you treat that class, even though it looks, it sounds like complicated, but it's just not. It's just like a regular variable of data type car, except it's an object. Okay, so you could put that here, but for now, let's just put that here and put it down here, back to where it was before. And so I created that class, and now I want to print the information out of the car. So initially, when I set this to kit and 0, when I print it out, you usually say system.out.println, and then you say car1 dot, okay, the object name dot to get its properties, right? Dot, I want to print the name. That's the name. Okay, so notice you can see here it says this field car.name is not visible. Why is that? close. It's not it, but close. What do you think? Why is that? What does it mean? What does it mean? It's not visible.
It's in private in previous program.
Yes, it's private. That's why I mentioned last time you cannot call another class data if it's set to private. Okay? Only inside here you can call its data directly. You see that we call this dot name directly. Right? If I change this to public, okay, let's save it, you see that it's happy because it's available to other classes to call in and modify the data directly. So now you have this thing called encapsulation, data hiding, right? That means that you cannot know what's inside. You cannot go in there and just modify the code. So now you have what's called a black box. If I change this back to private, okay, so that means I cannot just directly call that to do the settings. Well, how do you do it? That's why we have this getters and setters and getters, right? This one you control. So instead of saying that one, I'm going to say get me the name of that car. So you call the function to get it because the function is public, right? So this is always set to public. If I change this to private, I have the same issue because it's now private only to this class. So if I save it, you see that it has the same problem. You cannot access it, okay? And the reason why you do that is because you have control. This is the black box. All you have to know is, okay, this function here takes a parameter. This function takes a parameter. What happens in here from this class, I can't do anything to it. I cannot change the data. I don't know how it's implemented in here. All I know is if I put a value called kit, I can get it back, right? That's all I know. So inside the get name, that's all I know. I know that if I get the name, I'm expecting a name come back. Because in here, you can't change it. So I could say, hey, down here, return this name. I can say plus cool. You're not expecting that to come through the function, but now this class has control of whatever is inside. So the outside class cannot know that, right? So it's a black box. So we have this called the encapsulation of your data. Okay, so that's why you set it to a function to call it because you can change it here. That's one reason. What's another reason? Another reason is, let's say I have like 1,000 lines of code, okay? And if I were to do this, let me set this to private, to public. Okay, so public, and I can call this, you know, just name, right? I can use the variable directly to call the name. And if I have, you know, here, here, and here, so on. So they're all named, and they're cool, they're fine. What if later on you say, you know what? I don't really like this name here, called name. I'm gonna call it name X, right? Name X, or CX, whatever it is. Now what?
You have to go back and change all the
Yes. You go back and change everywhere, every occurrence in your code where you use the name is no longer name. It's called name X now. So if you use it 1,000 times, well, you have to find it 1,000 places and change it, right? So that's why it's not very efficient. So if you use the function get name, it doesn't matter what the variable is. You can change it to whatever you want. It's still going to return the name back to me. And all I have to do is just write down here. I just have to change one place here, and it changes everywhere else. It doesn't affect your code at all. Okay? So you set to private so that you have more control of your code. And so all the other classes, because when we build classes, usually you put it into a library so that other users can use it. Okay? And so when you make a change in your code, they don't have to worry about the initial values or of the variable name. All they know is the function is still going to be get name. And all they know is that that name, get name function returns a value back. Okay? So that's why it's important to set your data to private so that they can't access this variable here. Okay? So let me set this back. Alright, so we got the names, and then we have the car1 get name, and then if we were to run this right now, we have kit cool. Why is kit cool? Because I added in there, right? Because I screwed up in here. So there you have it, called kit. Okay? So I call it get name, and I can do the same thing here, and I can say, you can put in the same line of text, or you can put, here you can say car name, and then plus that, right? You can call it a different one here. This is the car speed, and then just say get speed. So see how easy it is. You can do this. You compile it, you get the data back right away. Okay? And if you want to set the initial value after this, oh, you know what, I don't like 0. And let's say if you have another property to start the engine, if the car's in motion, then you can set the speed to something else. Well, in here, you can say now the car's in motion, whatever it is, and then the car speed is set speed to maybe like 88, so we can go to the future or something. And so now I can put the speed down here and get the speed. So I set the speed, and then I get the speed back, and we have a new speed of 88. Okay? So this is how you can use other classes to do some other things for you instead of having everything in the same class. Okay? You break it down. You decompose the class to make it more specific to a certain object. Okay? So this is just an example of how you can break it down into other class. So in the car, you can even break this down further. You can say maybe the a brand class, okay, that is part of the car. Okay, you can have engine size class, part of the car, and so you can have this like huge hierarchical structure of classes all linked together. Okay, so that's how you would create objects. And if I have a second car, car 2, and you can see it's very easy to build. I don't know what this one is going to be. Maybe Bumble. Use something. Okay. So car 2 is there, and I want to print the car 2 information. Well, I'll do the same thing here. And as you can see, it's kind of redundant. And car 2, car 2, car 2, and this is car 2, and so on. Oops, 1. So at let's just say 45. Oh yeah, thank you. Okay, so I just duplicate my code, and if you run this now, you see that car 2. Oops, I did change the speed. Yeah, that's right. Yep, car 2, and now I have the different speed for different car and so on. Okay. So if you look at this, it's not really friendly. It's a lot of redundant code. And again, we don't like spaghetti codes, okay? We want to compartmentalize these and put into a different method. So instead of doing this, I can put this out into a print statement or print function. Okay, so I'm going to go down here and create a function to print. So public void, I'm not returning anything, just print to the screen. So we can say display info or something. A display car. Okay, and I'm gonna pass. So if I do this, I can copy this. I'll just say the speed here. Copy these 2 lines and put it in here. Okay, so what do I need in here? What do I need? I need the car, right? The car is a car type, so I need to pass a variable here called car. And it just changes to car. So I can pass any car here. I can pass car 1, car 2, car 10, doesn't matter. But this will print out the car. Okay? So I can go back and say, I'm going to turn all these off. In here, I can just say display car 1. information. Oh, I have to make this a static. Okay, makes it static, so it's available to the public here. So I'm going to display car 1 information, and if I run this now, you see that it displays car information. Okay, if I pass in car 2, I just call the function and pass in car 2's information, and I have both information car 1 and car 2, right? And let's just say I want to set the car 1 set the speed to maybe like 88, and then also want to set car 2 speed to 55. Okay, so I set the speed and print, set the speed and print, and then I have the new information here. Okay, so the print does all the printing for you, so you don't have to do this like 100 times. Okay, make it efficient. There's 2 lines of code, and also you take. So to format the other one, like I did in my example, you could go and say system.out.print line. Say like this. That's what I did, right? I can stuff like that. You say car, and then usually I see car 1, right? Something like that. Well, how do I get the 1 here? If I do this, if I run it, it's going to say car 1, car 1. I want this to say car 2 and car 3 and car 4 and so on. So how do you do that? How do you tackle that issue? How do you make this one dynamic? Any idea?
Separate the first dashes and font and
Okay. So you could, right? So you could do something like that. And you, yeah, concatenate. What am I concatenating here? What should this be? I mean, there are many ways to do this, but one example will be how would you do it? If I pass the car 1, I want this to say car 1. If I pass car 10, I want that to say 10.
Can you increment it?
Increment.
That number.
What number?
The 1. So every time it prints out increments.
What if I print car 45? I print car 1, next line print car 45. I don't want to say car 2. Yeah, so the car number, for example. I mean, that's a way. So one way.
Move it in increment, like Jason said?
Oh, okay. I want to print the car number, right? So if I print the car 1, maybe it has an ID of 1. Car 45 has an ID of 45 or something like that. Okay. And of course, there are many ways. One way is you just pass a different parameter to it, right? You can pass a different parameter. This is like the hard way. You say car 1 pass 1, car 2 pass 2, and then now I have to fix my function because my function, you know what? Let me move this to the. Oh, sorry. So I take another parameter int I or something, and then this is just I. Okay, and I'm going to plus that to. So car I. So I'll print car 1 pass 1, car 2 pass 2, car 10 pass 10 in there. Okay. Again, this is just one way. There are many ways to do it. So when you execute this, you see that car 1 has that, car 2 has that.
How did you get it to, just by display car 1, comma 1, car 2, comma 2, that just increments it? I mean,
Yeah, I could put that way. Yeah, I could just say car 23 doesn't matter. And if it's like, this is for 23, for example, and then now, this is just a numeric literal I pass to it. So the first one's going to say car 1 is that, car 23 is that number, whatever number is. Okay? So I'm passing the numeric literal to the function to print it out, basically. Because I want this number to be printed.
You still have to type that line out.
Yes, you have to
The
include
line's
it.
still got to be typed out.
Yes, you still have to include it so that I, the number here, comes in dynamically. Okay? Depends on the input. That's one way. Another way is typically you would modify the car so the car has a private ID, right? And then here you would say ID, int ID, and then here you could say set ID, or this ID is equal to ID, private int, like that. Okay, and then when you initialize your car, you say car speed of that one ID of 1, 2, 3, and then ID of 4, 5, 6, right? We do this way, and then so here I can remove this part, and back to what I was before. I don't need this anymore. And car, I can say car dot get ID if I have the ID method in there. Okay. You see how you can initialize these data, right? So here I could have another function here to get the ID. I could say I could get the getter, the void get ID, and then it returns this ID. Not end type. Okay, so when I do this, you see that if I run this, it gets the ID for me, 1, 2, 3, because I initialized the car with the ID of 1, 2, 3. The second car is 4, 5, 6. So when I pass the car over to this function, that's all I pass, just the car object, because all these properties are associated with that car. And how do I get those information? Well, just car dot something, right? Car one dot get car dot the ID, get the name, get the speed. If you wanted to have other properties, dot get something, dot set something. Okay? So
In the real world, you really do pulling in a database with all of these fields.
yes, so in the real world, you would do like, you're still gonna have these in here, but the actual data will come from a database. So you read the database here, and then you put the data to this variable here. And when you modify, and then you update, you send the data back to the database. Okay, it's like going back and forth this way. Okay. Okay, and so are there any questions? Okay, so in the homework, it asks you to create a an object called sandwich, class sandwich, and that sandwich has two fields. One is bread, one is filling, right? So by the same token, you can say I have another class here, and you can say here maybe like car. I don't know what that is. Okay, I guess we'll call it driver. Okay. So a driver class, and this class is going to have a car of car type, car 1. And so you have another class. If you have like a different type, we'll put it here as well. But in this class, then you would well, it's kind of the same thing as I did here. Instead of driver, I could just put it out here. Okay, maybe just do this example here. Let me move this out here. So so basically just move that into the global space. So in here, I would just initialize it in here. Like we did earlier, it doesn't matter where you put it, right? You could put it in here or put it out there. Oh, actually no. You want to put new out here. You want to initialize it out there. You could do it in here, do it out here. Yeah, no, we ran through the problem with the static thing, but you can't put it in here, but out here, or probably not in the static space here, because if you do, you run into the issue of not being able to create call your methods object down here. So how much time do we have left? Are we out of time? Okay. Okay. So I'm going to show you just a little sneak peek of how that could have been done. And so the driver class. So the driver, I can have car1. Inside this constructor driver, okay, I have the car type, car, what we call it, car. And then I'm going to set so I have a getter down here, right? So you have a same as before, public void set car of car type called car. Okay. And remember, these are objects. Okay, it's a classical object, and it's not an integer type. But the way you do it is exactly the same, right? You do exactly the same as you would the other one. So this car is going to have a set car. So you can set. This car is equal to this car here. This car here. So it looks very exactly the same. So I want to set. The get will be the same thing. Get car. So what type of data is it going to be? When I'm getting or returning a data type, what type is it going to be? Why is it string? So if you look at this, right? I have a string name or int ID. I'm getting a type int back. Okay. Here I have a car, type of car. I'm getting a car type back. Okay. So return this car. Okay, so the data type matches this data type. You see it? This car, we call it car because it's car because we call it car. But if you think of a string, it's a string, right?
It's a data type.
Yeah, string is a data type.
But a car is
A car is a data type of car. We call it car. It's a data type of car. What type is it? Oh, it's a four-engine car. It's a Ford car, whatever it is. Okay, so that class becomes a data type. It's an object. I know it's kind of hard to
Yeah,
wrap your head
yes, I
around it.
am
The
getting it.
prior class named car. and you
Yes.
created an object, now you can use it
As a data type.
oh,
Okay, so I can treat exactly the same as I did. This is, if you think of this as string, then the car is a string, so I return a string type. Or it's a car type, or it's a class that I call car, so I'm returning the car type back.
Okay.
Okay?
Yeah.
So when I set, I'm setting the car, and it's not returning anything. So if I have another car, another class here called maybe bike, then I have bike type, right? Plane type, and the data type will be that. Okay, so in here I can now say set car, this variable car, and then also so that's it.
Okay, so is that why the other data types are called primitive data types? And
Yes.
this isn't- okay.
Yes, the
But
primitive,
okay.
the primitive, those are built into the program, but the
Okay.
int, the double, and so on, those are primitive type. So the string is exactly the same as car type because string is a class. Okay, that's why usually your classes are capitalized. So anything you see with a capitalized word in there, it's a class. Okay, so yeah, that's a class. When you create an input, we call it what? Scanner, right? S is new scanner. It's a class. Okay, I just didn't import it, but once you import it, and this is a library, but it's a class. So it's type scanner. So if I were to say, hey, you know what? I have a scanner up here. Let's go in here. I have a private scanner called input. And if I include this, so that's imported. It's a class in here. So I have a new scanner in here. Okay, so I have an object called scanner. And I could initialize it. I don't have to, it's fine too, I think. I could just do that. Right? So when I initialize the car, I could now say, you can do exactly the same as you do here. Or if just for the shortcut, I'm going to say input is equal to new scanner. Okay. So it's because every object type you have to use the new to instantiate that object. So now scanner is input here is an object. So in here, if I have a function to do an input, let's just say you know, public type you know, string and get you know, input or something, right? And then you can use that scanner in here and return the input of next string, right? Next string was the next line. I think it has a next string. I'm not sure it has next string. Next line is a string. Okay, so you can see, just so that you can use these built-in classes as your field as well. So if you have a scanner for reading input here, you can pass this input around to those functions to use it, so you don't have to create 1,000 or 100 or 10 or 20 different input readers. Okay, so by using what's already available to us, like the scanner and the print, you can see that you can also build your own type of data type called car, called sandwich, called bread. Okay, sandwich filling. It's a unique data type that you create, you get a control. Okay, and so once you grasp this concept of creating classes and then you instantiate those classes into objects, and then you can pretty much build any object type you want. Okay, and you can break it down, and eventually you'll get to the point that all your data type are usually mostly objects. Why? Because it's easier to maintain your data, contain your data. So like car, right? I have this data here, name, speed, ID, and I access it by just passing one parameter to this function, and I get all the data back by using that single object, get ID, get name, get speed. So I don't have to pass like 10 parameters to this function. Imagine you have to get all the ID, the name here. The non-object way is to pass the car as a string, name, get the speed as an integer or the double, and you pass the other ID as an integer type. So you have to pass all three of those into the function. And eventually that function head gets really long. Okay? Whereas you pass an object, just one object, then all these are chained together inside that object. So you can access those data just using the dot notation. Okay? So you pass the object, you pass everything it has together with it, with that object. And you can choose to display or not display those information. You can set in here, you can delete data in here to those objects however you like. Okay, so I hope this is gonna be maybe clarify a little bit how you would create your bread and your sandwiches. So when you create those three classes, right? So your main, you're gonna have a sandwich 1, a sandwich 2, a sandwich 3, and you say new sandwich, and you're gonna set the bread type, the calories, okay, the filling type, serving size, okay, and then you're gonna do a calculation. So display will be similar, and I'll let you do the calculation part, right? So you're gonna pass another function down here somewhere. You can say, you know, public. You're calculating something, you're returning something back, right? So if this were calories, then usually double, and it's gonna say get total cal, right? Something like that. So what are you going to pass to this calorie? Or if I get total cal, in this case, if car were bread, then I would say car. And then in here, I would return, let's just say, car.speed, get speed, times 4, whatever it is. Okay? And then here I'll say maybe a variable called double total speed is equal to get speed. That's a get calorie, doesn't make sense, but get calories. And I'm passing the car object, car1. And that's all I'm passing, just the car1. And it's going to return that information back to me. Yeah, we'll make this static. Okay, so it does the calculation here, return the total back to this total speed, and then you can now display that to the screen. Okay.
How does everybody do on that, typically?
On this part,
On this, in the previous classes, how did everybody do on this assignment?
oh, this is the first one for you guys. I haven't used that one for anybody yet. You guys get lucky.
No.
You guys get lucky.
I know we'll all do great on it. We'll make you proud.
No, I'm sure you will, and you make yourself proud. So try to see how far you get by next week. Okay, so I'll give you 2 weeks to do it. And if you struggle, if you still can't figure it out by next week, we can go over again a little bit more. But so build your classes. Okay, so you have 3 classes to build, and those 3 classes should look just like my car class. Okay, you have the bread type, calories, and then you have the constructor, set those values, setters and getters. That's all for that bread type. Another one for the sandwich filling. You have the type, and then the serving per serving here. Set those up. Okay. Then you have the third class. It's going to be like the driver. So the driver class is going to have, instead of this, it's going to have the bread as a type. You have the filling as a type. Okay. So when you do this, your constructor will look car, and then you have a scanner here. So think of this as like bread, the sandwich filling, okay, for this driver here. So I can set car, and then can set the scanner input here. And then your main program, which is going to call the test sandwich, will look something like this. You won't be doing here. You call this sandwich here. So this would be like the driver. Instead of car, it would be like driver. So driver 1, okay, driver 2, and so on. So for example, driver. Okay, so a driver I have, if I have call one scanner, then when I create a new driver, D1, new driver. What type of data does it take for driver? It says the first is a car, second is in scanner input, right? So the first is a car. It's going to be car, so down here. I create the car first. I'm going to pass the car, and the second is a scanner. I don't have a scanner type, but assume if you have a scanner here. Had to be the same type, okay? So scanner, and put here. I'm just using scanner as an example. It should have been like the filling and so on. So you have the input here. So I'm going to pass the input to the scanner for the scanner part. And this is how you will create your first sandwich. Okay. So assuming if I have like, let me move this down. So I have my bread type, bread, sandwich filling. I'm still gonna call them and then fill those data type, right? So the bread type could be rye, this many calories. The sandwich filling is gonna be whatever that type is, then that many calories. Okay, so I create those objects first, and then when I create my third object called sandwich, I'm going to pass in these two objects here to its constructor. I'm passing the car1 into this, I pass the input into that. Okay, and then now when I output the data of the driver one's information, du1, I want to put the car's information here. So du1 dot get car, it's all chained together, get name, right? So the du1 is this class called driver. The get car is, because the get car is right here, so it's going to call this driver. I have a car class, and this car is inside here, the get car. So inside the get car, it's going to call the car. Now it's going to go and trace over here and get the name. So it's like it takes two classes to reach here. In order to reach here, I have to go through the racer here. I have to go through the driver class, and then I have to go to the driver class. I have to go through the get car function, which is inside the driver class, right here, get car function, and then inside that I can go and get the name from the car class over here in the car class. Okay, and I will put this into a diagram so you can see it. You see it easier to understand to see it. Okay, so I basically have like three different classes. Okay, your main class is, this is your program class. You create two objects of different types. Okay, then you pass these objects to a third object, right? So this object takes two of these objects and put it in there, and so on. And so I will diagram this again into a a nice diagram, so you can see how they work and how you can follow the chain that way. But see if you can figure it out, and try your best. And if you get stuck, don't worry. We'll go over this again next week and make sure you get it. Okay, because this is if you get this, then I think you are in a really good position to really kind of understand how object-oriented work. Okay, I know it's a lot to wrap your head around these classes, but just treat them as data type. Okay? So class is confusing, or use them as data type. Okay? All right.